When Megalodon finally vanished, nothing took its place. Not immediately, not eventually, never. If the climate alone ended something that ruled every ocean for 19 million years, why do we find its teeth in near-freezing water? And if the answer really was just cold, why did nothing ever fill the void it left behind? Usually when a dominant predator disappears, evolution moves on. When the dinosaurs died, mammals stepped up. When the reptiles disappeared, the sharks took over. But when Megalodon died, the apex of the entire ocean just stayed empty. The standard explanation has always been climate change. One theory that has popped up time and time again is that as the planet got closer to the Ice Age, it brought about colder water temperatures, and it simply became too cold for the giant shark to cope. This change in temperature could have affected Megalodon directly, or it could have impacted on its food source. As the climate shifted, more productive environments with more food began to take shape closer to the poles, so whales started to spend a lot more giant, fast, heavily blubbered insulated baleen whales evolved, and they migrated into the freezing, nutrient-rich waters of the polar extremes. Megalodon, tethered to warm water by immense metabolic cost of keeping 200,000 pounds of muscle heated in freezing conditions, could not follow. The giant was effectively landlocked in shrinking equatorial bands, watching its food supply migrate toward the poles. That's when researchers found something nobody expected. Zinc isotope analysis comparing early Pliocene great white teeth with Megalodon teeth from the exact same fossil beds in North Carolina revealed something shocking. Their zinc isotope ratios were virtually identical. The much smaller, newly evolved great white had successfully occupied the exact same trophic level as the gigantic Megalodon. A great white needs a fraction of the calories Megalodon required. It could adapt to cooling waters. It could pursue the same prey base more efficiently. Modern analogs suggest that great whites would have aggressively predated upon juvenile megalodons in their coastal nurseries, cutting off the species' ability to replenish its numbers. Being bigger is great if it gives you the advantage of having access to a different food group. But when it no longer does, it means you're just bulkier and require more food to survive. During the Pliocene, 55% of large marine mammals vanished. 43% of sea turtles, 9% of sharks. The buffet that had sustained Megalodon for 19 million years was being cleared from the table. And that's not the worst part. The real killer wasn't a predator. It wasn't a catastrophe. It was Megalodon's own biology. The very traits that made it an unstoppable titan. Its extreme size, its massive caloric demand, its endothermic furnace, became the anchors that dragged it into the fossil record. Starved by migrating whales, squeezed out by shrinking warm water, the oceans could finally host 25-meter whales. It took Megalodon's extinction to make room for the largest creature in the history of life on this planet. Megalodon didn't just live in its ocean, it shaped it. One of the most formidable predators to ever live, and it never left us a body. We have thousands of its teeth scattered across every ocean floor on Earth, but no skeleton, no final answer. Just fragments of something that wants to find the absolute limits of what a predator could become. The ocean swallowed it whole, and what grew in its absence was bigger than anything Megalodon ever hunted. And somewhere out there right now, a tooth that once sat inside a living Megalodon is resting on a sea floor, waiting to be found.